Hello guys, welcome to Super Easy Physics and Mathematics. Today we are looking at the Mathematics Paper 4 Extended February-March 2023 edition, and we're going to be starting with question 3. Wow, no, maths is going to take 2 hours 30 minutes, so if I'm going to explain in the video, it's going to be very long. So I decided to let's take the question bit by bit in a special way, man. Let's jump in. All right, this question 3, and this diagram shows a cylinder containing water. There is a solid sphere touching the base of the cylinder. Half of the sphere is submerged in the water. The radius of the cylinder is 12 cm as shown, and the radius of the sphere is 3 cm. Now the question, the sphere is removed from the cylinder and the level of water decreased by h cm. Show that h is equal to 0.125. So we're going to prove this now. All right, so we're looking at the 3a. The sphere was submerged inside the cylinder, and basically what we want to do to help us solve this problem is that, remember, by principle, when a solid is submerged in a liquid, that solid is going to displace the amount of liquid that is equal to the volume of the solid. That is just the foundation of this question. So how do we apply that principle? What was submerged in the water was a sphere, half of it. That is what I call hemisphere. So the volume of the half of the sphere will be equal to the volume rise in the cylinder, which is equal to h. So if I remove the sphere from the cylinder, then the volume, the height of water in the cylinder also going to fall in such a way that the height of the water drop in the cylinder will be equal to the volume of half of the sphere that was submerged. So by so saying, so we now say half of the sphere, the formula of the volume of a sphere is 4/3 pi radius cube. So it's equal to the volume of the water rise in the cylinder. So with that, we can cancel our pi from both sides. So okay, so what is the radius of the sphere? 3. And then what is the radius of the cylinder? 12. So simplify, but before we simplify, let's cancel out the pi. So we are left with that, and we can now make h subject of formula. So divide both sides by 12 multiply 12, that is 144. Then cancel out the numerator. 2 can handle 4 in the numerator, and then 3 can handle divide 27 to give us 9. Right, so numerator 18, the denominator 144. So if we cancel out that, you can give us 1/8, then divide, express it in decimal. So that has been proved. So we have a 3 mark. Let's go to the next question. Okay, question 3b. The water in the cylinder is poured into a different cylinder. So I decided to bring this white cylinder here, which is having a smaller radius, and the depth of the water in the cylinder rose by 18 cm. So the water in this cylinder rises by 18 cm. So calculate the radius of the new cylinder. So the water rose by 80 cm. So what we're going to do, then the radius of the cylinder is what we are looking for. That is the capital R. Then this is this original cylinder, so do you know this is the height of the water we have there. So in principle, we say the volume of water in cylinder A will be equal to the volume of water in cylinder B, because it is the water in cylinder A, the bigger cylinder, that was poured into the smaller cylinder. So let's do that. So volume of cylinder A equals to the volume of water that was poured from cylinder A is equal to the volume of water poured into cylinder B. So with that, so I'm going to be using cylinder A, that is the red, and then cylinder B will be green. So putting the volume of a cylinder, so substituting the parameter. Okay, let me explain this part here. Why is the height of water 3 take away 0.125? You know, we are not talking about cylinder A without the sphere inside the cylinder. So the sphere is no longer inside the cylinder. So the volume of the water has dropped. From the proof that we did in question 3a, the volume of water decreased by 1/8 when the sphere was removed from the water in the cylinder. So that brings the height of the water originally to 3 take away 0.125. So let's simplify further, and then we make R, which is the radius of the new cylinder B, subject of formula. So with that, pi can easily go away from the numerator and denominator. So expand. 12 square is the same thing as 12 multiplied 12, and then 3 take away 0.125, that will give 2.875. okay, then divided by 18. So with that, we have 144 divided by 18. Then that will become R square is equal to 23. Square root of that we give 4.796. So approximately to 2 decimal points is equal to 4.80 cm. So that one is solved. Let's go to the last question. The sphere is melted down, and some of the metal is used to make 30 cubes with edge length 1.5 cm. Calculate the percentage of metal not used. Wow. So in this case, the metallic sphere was melted and it was used to construct 30 cubes. So by principle, so we have, this is the sphere, the green 3 cm radius, then it was melted to create smaller cube, the red cube, and then the length of the cube is 1.5. So what we are going to say, the percentage of metal not used is going to be the volume of the sphere, take away the volume of 30 cube divided by the total volume of the sphere, expressed in percentage. So we have that. So let's substitute. What is the volume of the sphere? 4 pi r cube. Take away the volume of a cube is length times breadth times height. That is 1.5 cube. Then there are 30 cubes, so you multiply that volume by 30. That's why we have that. Then you divide by the volume of the cylinder. So put your parameters, and eventually we'll have this value. So break it down and divide. That becomes 10.4753. So put in 3 simple figure, 2 decimal place, that is 10.46%. I know that you are a student who want to succeed. You are looking for a way to ace the exam, and I'm here to help you. So just subscribe. It's a smart choice you need to make, because CEPAM is ready to help you by uploading more examination questions that have been solved. Please kindly comment on the video and feel free to ask any question. I will try to respond back. So let's go to the next question.